Okay, so for the first question that we've got here, we're going to start with the topic of cross sections. Like, I know when we started volume, it was like, oh my god, I'm going to die, it's volume, it's terrible, it's the worst thing ever in calculus. But hopefully now that we've had a chance to work with it, you're starting to get the hang of how those things work. So let's start with this question, and the topic again, we're going to start on, the first few are all going to be cross sections. So see if you can set up a proper picture to help you answer this question. While you're doing that right now with your picture, I'll just remind you that no matter what technique we're talking about, whether it's the shell method, the disc method, the washer method, or the cross-section method, they all have the same idea. You take a slice that represents one piece in the area, and you add up all the slices, will give you volume. Okay, so that's what you should be thinking about for this. For cross-sections, we said it was, you integrate the area function. So your job is to find that area function. Okay, so some people have forgotten how to do their graph. I'll just remind you that roughly, if you wanted to show me an exponential graph, it would look like this, right? This one has a transformation though. What's the transformation that's happened to it? There's a reflection, and it's affecting the x values. The x values that jump across mean the reflection happens on the y-axis. So this exponential graph is now going to look something like this. We don't need a perfect picture to answer the question. Basically, when we set up our problem, it tells us it's bound by the coordinate axes. Here's my line x equals 3. I don't know if that's really at x equals 3, but I just need it somewhere in my picture. And here's my graph, something like this. That's enough for me to have a picture that I can use to help me answer the question. And this is the base of that object right there. Okay, so that's what I would do as my initial setup, and that's enough. Your picture doesn't have to be incredibly accurate. That's enough to get us going. So it tells me that the cross sections are perpendicular to the x-axis. So will this be a vertical or a horizontal slice? So does the bar go like this, vertical, or like this, horizontal? Yeah, it's vertical, so it's perpendicular to the x-axis, so maybe this is one of the possible slices. Okay, I cut into the object right there, okay? And this is the green shaded area, that's like the bottom, like the base. If it was sitting on the table, that's the stamp that it would leave behind. So this is sort of, it's coming up out of my whiteboard right now, straight out, and I slice it there. It's a square, so it's going to look like this when I see it from one side, where the slice happens. And the nice thing about a square is the area is any side squared. So, for example, that side is an easy one. I can see that for any value of x, it has a length that's going to be equal to e to the negative x. So the area for this particular square is going to be e to the negative x squared, which will be e to the negative 2x. Okay, so that gives me my area function. I'm going from 0 to 3 of e to the negative 2x dx. And I know I've talked about this, but you know, for questions like this, you should be able to do it without resulting to substitution. If you can't, then do substitution. Remember, you always want to save time where you can. So, what could be a time-saving constant to add to this integral? Negative is correct, and yeah, a half and a 2, right? Those are the two things that I want. This piece here is going to end up, if you think a couple steps ahead to chain rule, that piece is going to add a negative 2. So if I wanted to add a negative 2, that means I have to add a negative half. So then I can do my integral fairly quickly. It'll be negative 1/2. This here is already set up to go e to the negative 2x from 0 to 3. And that means at 0 it's going to be, at 3 it's going to be negative 1/2 times e to the negative 6 minus negative 1/2 e to the 0. That's 1. So I end up with, this is a positive, so it's going to be 1 minus 1/2 e to the negative 6 which if we put it all on a, sorry, that would be 1/2 minus 1/2. So if we put it all on a common fraction here, it would look like this. And that, I believe, was choice A in the original problem. Okay. So the next graph you should be more familiar with, but that's enough, right, for us to work with. As long as you have a general idea of the picture, that's enough. You don't need a perfect picture. So let's take a look at the next one. Need a minute on that.
It's like I can see the.
Oh, the projector's in the way. Okay, here, I'll pause it, let you copy that. Okay, so this one, again, you should be more familiar with this picture. So see if you can draw the picture. We're still doing the cross-section method, and we're still going perpendicular to the x-axis. Okay, so I'll let you come up with a picture for it. So this is a picture that you should have of the base of the object. And now we need to slice perpendicular to the x-axis. So perpendicular to the x-axis is going to come down here like this. And that means it's still a square, according to the question. So I'm going to look at that slice. And now I need to figure out how tall is one of the sides in my square. So if I look at it, this is the easy side to pick. Okay, the height is 4x squared. So that means my area function, whatever position I'm at for x, the area is going to be 4x squared, all squared. So it will be 16x to the 4. I'm going from 0, which is here, because it says it's bounded by the x-axis. And first quadrant, so we get 0 to 1 of 16x to the 4 dx. And again, the integrals are the easy part, so if you've gotten this far, I don't doubt that you have the right answer. So that's not bad, it's just 16 over 5, which is D. Any questions about that one? Can I just see, because I know cross-section was a tough one the first time we did it, can I just see how many people are able, they were able to do this question now, it's working for them? Excellent, good. Pardon me? With calculator, that's fine. As long as we're getting there, that's good.